All right, here we are, already zooming into chapter 5. Shazam! It's going so quickly, isn't it? Can you hardly believe 7th grade is going this fast? It's amazing, isn't it? They always say time flies when you're having fun. Here we go. All right, so this chapter, we're going to do a lot of work with computation, and I need you to have your calculator. So if you don't have one right now, pause the video and go get one. Okie dokie, here we go. I need you to make sure you've got this heading up on your screen now. Chapter 5, Section 1 is all about ratios and proportions. Some of this will be review, and then, of course, then we take what you know, build upon it, and go deeper and more intensely into the subject area. All right? Ratios and proportions. All right, so here is your learning target for today. I can find equivalent. Oh, that's a good word. Equivalent. That means they have the same value. Equivalent ratios. Okay. That's supposed to be an I. I can find equivalent ratios. That's the first part. And then we use those to create proportions. There's another good word. Awesome. Proportions. Sweet. There we go. Now, I suppose as we venture in here, we better make sure that you understand these words that we are using in our learning target, for goodness sake. So here's the first one, ratio. Ratio. Ratio is simply a way that, or a term that we use that means we are going to compare two numbers. And actually, it could be variables as well. Okay, so we're comparing them. Oftentimes, I just have you think, basically, if you think of it like a fraction, because sometimes that's exactly how we write it, is like a fraction. And here's another way to think of it. Ratio, fraction. And look at the letters that are inside fraction. Ratio. Oh, isn't that cute? Nice. Okay, so this is what a ratio is. You compare two numbers, and there are a bunch of ways we can write it. Let's say in my family, and I'm talking about like when I was a kid, I have one sister, and so my poor dad was kind of outnumbered. So if I was going to compare, let's say, the girls to the boys in my family, I would say the ratio was going to be 3-1. There was my mom, my sister, and I, and then my dad. So I could write it this way as a fraction, okay? And we'd call that either 3/1, or sometimes we use the word 2, T-O, not the number 2, but 3-1, girls to boys. Sometimes we might use a colon, so you might see the two dots like this, 3-1. Sometimes we write ratios that way. And sometimes we might just flat out write it in words and say 3-1, like that, okay? All of those mean the same thing. Mathematically, we'll most often write it as the fraction. So when I say ratio, you're thinking, okay, two numbers. I can use all of these different formats, but usually we'll write it as a fraction because then we're going to start doing some math. And here's exactly why I say leave an improper fraction improper, because we need to now so that we have a numerator denominator because we're comparing the two numbers. Okie dokie. Sweet. All right, so that's what ratio means. Okay, and I think we just talked about this. Okay, good. So let's talk about my favorite food. Woo! Of course, besides coffee, then would come M&Ms. Love M&Ms. Okay, so let's say we've got like a little snack size M&Ms, and we rip open the bag, and of course, you notice you count them all, right? Yes. And then you have to sort them by color because you cannot just eat them like, "Ugh." You have to sort them by color and then even things out, right? Don't you eat your M&Ms that way? I do. Okay, so here we go. Let's say we have 7 red ones, 9 brown ones, 6 orange, 3 green, 5 blue, 2 yellow. Okie dokie. If I asked you, hey, could you please Now write the ratio of blues to browns. Okay, then all I need you to do is look at our list here. Blue to brown. Let's see, blue, 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 blue. 5 to brown, 9. 5 to 9. And you could write it as a fraction. You could write it this way. You could write it with the word TO. Okay, I think I'm just going to stick with fraction way if you don't mind. Okay, how about blue to all? Blue was 5. So whatever word comes first, that's your numerator. Blue to all, 5 to 32. Okay, yellow to all, 2 to 32. Hold on. That's not its simplest form. So something I want you to recognize is if you get a fraction that's not in simplest form, put it in simplest form. Okay? Yeah. And yellow to orange. Here's yellow, 2. That's my numerator. Orange is 6. Oh, whoa, 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 whoa. Don't leave that like that. 2 to 6 in simplest form is 1 to 3. Ah, piece of cake. All right, let's keep going. Now, proportion, because remember in our learning target, we talked about proportions. So what is a proportion? Well, first of all, I want to tell you that it is a math sentence. And now you're saying, oh my gosh, please, can we not have language arts in a math class? Sorry, you need to learn how to tie this all together, and it works that way. It is a math sentence, and it's a math sentence that has an equal sign in it, okay? And basically what you are doing is it is an equation that has two equivalent ratios. In other words, two equivalent fractions. Aha. Aha. So, for example, let's use my very, very, very favorite famous fraction, 1/2. Great fraction. Can you think of a fraction that is the same value as 1/2? It's just not in simplest form yet. Maybe you'd pick 3/6. Okay, here we go. 1/2 equals 3/6. This whole equation is called a proportion. Okay, I can't even spell proportion. There we go. So this is what you're looking at today. You notice those two fractions are equivalent to each other, and because of that, when I set them in an equation equal to each other, that's what a proportion is. Nice. So let's look at these examples. 9/27. There's a beautiful fraction. It says find two ratios that are equivalent to this one. All right, so give me one that's equivalent to 9/27. Well, if I put that thing in simplest form, that's 1/3. There's one of them. Can you come up with another one? Yeah, lots. Geez, now that I have simplest form, I can go to town. 2/6, 3/9, 4/12, 5/15. Oh, I guess I'm kind of overachieving right now. You only need 2, so just give me any 2 that work. Psst, there's a million correct answers here. We might not all have the same ones, and that's okay. Oh, look at this one, 64/24. That's not in simplest form either. Great, great value there. This in simplest form is 8/3. Notice it's improper. Leave it there because a ratio means I have a top number, a bottom, 2 numbers. Okay, and that's why I'm writing them as a fraction. Leave it improper. I don't want the mixed number 2 and 2/3. I want 8 to 3, 8 to 3, 8 to 3. Okay, give me anything else that's equivalent to that. Oh, maybe you want to say 80/30 or 16/6 or 32/12 or I mean there's tons and tons and tons of possibilities. You just have to give 2 of them. Okay. Let's see. What else are we going to have you do today? Oh, simplify and tell whether these ratios actually make a proportion. 3/7 to 2/18. Well, put this in simplest form. 1/9. Put this guy in simplest form. 1/9. Are they equal? Well, yes, they are. The answer to the question then is yes. Show the work to prove it. Tell me yes or no. How about this one? 12/15 and 27/36. Yowza, that's a lot to say. Okay, 12/15. So look at that. I'm thinking, oh, factor a 3. And if I factor a 3 out of here, my numerator would be 4. My denominator would be 5. Okay? So 12/15 is equivalent to 4/5. 27/36. Yikes. I'm trying to find that greatest common factor there. And I know a 3 will work, but I'm looking at these and I'm thinking, a 9 works. Yep. So if I factor a 9 out of the numerator and the denominator, I get 3/4. These guys are both in simplest form, but they are not equal to each other. They do not form a proportion. No, nope, nope, nope. All right, so let's look at this. Here's a science application. At 4 degrees Celsius, you see the rest of the world uses the metric system except for good old America. Us, I think Liberia and Burma. 3 countries, 3 on the entire planet Earth that don't use the metric system. 4 cubic feet of silver has the same mass as 42 cubic feet of water. So see, that's why they wrote this and this. Now, me personally, I always like to think, okay, so it's at 4 degrees. Okay, I guess the degrees doesn't matter. It's 4 cubic feet of silver. That's what's on the top, and the water is on the bottom. Okay, silver to water, silver to water. All right. So now they say, would, that's why they have this question mark here, would 210 cubic feet of water, hold on, water was in the denominator, so that's why they put that there. Would that have the same mass as 20 cubic feet of silver? So this is the question. Is 4 to 42, that ratio, equivalent to 20 200/10ths? Get it in simplest form. Okay, let's see. Divide by 2, I'd get 2 21sts on this side, factoring a common factor of 2. On this side, oh, I love when they end in 0 because that means it has a common factor of 10. When I divide or factor out 10, I get 2 21sts. Winner, winner, chicken dinner. Yes. So the question is, would they have the same mass? And you can say yes. Yes, they would because they form a proportion. They're equivalent. All right. So if you see 4/15 and I say, hey, can you give me 2 ratios that are equivalent to that? If this guy is already in simplest form, you just have to choose some number that you are going to multiply numerator and denominator by, because that numerator over denominator of the same number is 1. Oh, you could say like 8/30ths. That's going doubling everything. You could say 12/45ths. You could say 40 150ths. That all works. Okay, got that idea. Number 2, 8/21ths. Yeah, that's in simplest form too. So I like multiplying by 2 because I can do that in my head pretty simply. I like multiplying by 10 because I can do that very simply as well. There's 2 possibilities. You have a lot more that you could come up with, an infinite number of answers. Last but not least, is this a proportion? 16/10ths, 32/20ths. Well, if I simplify, put this in simplest form, this first one, 16/10ths, that becomes 8/5ths. 32/20ths, they can both be divisible by 4. They're both divisible by 4. So when I do that, I get 8/5ths. They are equal. The answer is yes. This is the kind of preliminary stuff you're going to do. If you're already jumping ahead of me and thinking about, hey, I know something about how to check for proportions that way, we're getting there. Just hold your horses, okay? All right, so here's what I want you to work on then for your assignment. Pages 218 and 219. This is in the textbook, okay? Your assignment is to do these selected problems, and I'm promising I won't mess up today like I did before. 11 to 47, and do them all. Okay, now you're going to be perhaps tempted to whine about this, and I'm going to say, oh, stop. A lot of it will go like this. In addition, I'm giving you a whole bunch of odds. Psst, hello, the odds are in the back of the book. You can check. Okay. All right. Get started. Get a sheet of paper, get your textbook, dive into this. It really will go very quickly. And as always, may the force be with you. Good luck.